Hello everyone, I'm Claire, and today let's talk about how does the Taylor series work. In this video, so first let me introduce. Let me talk about this I will apart this problem to 3 parts, and this is the first part, or we can say the first chapter. Okay. So first let me have an introduce of today's problem. And so we'll talk about the secret of Taylor series. Actually, just how does the Taylor series actually work? So first let's talk about using first let's gonna write out. So we know in the last video we're gonna write P of X, and we focus at A. So first it's f of a, and then we plus. Then it's, look, this is d of f of d of x, and then a. Good. And we just times x minus a. And x is what the value that we need to calculate. And plus df. Okay. T2. Just the second derivative. I'm plugging a, and x minus a squared. So we are actually gonna, we have a 1 or 2 at the front of it. So we're gonna write it out and talk about what it actually every part means. So we just write it out like 1 over 2 times d f squared. The dx right here, the a. And times x minus a, and times another x minus a. Good. And then we plus. So next part we're gonna times out 2, so it's 1 over 3 times 1 over 2, and times, okay, here's df, okay, t3, and right here dx t3, okay, and it's a. Bracket a, so we just the third derivative, and we plug in a, and times x minus a times x minus a times x minus a, and plus point, so on. And we have infinity terms. So this is the last video, and so let's talk about an example if we think about e to the x. So e to the x. So first it's 1 here. So first let's draw the original function. So first the f this function, right? So it's e to the x now. E to the x is x. Okay. So now first let's think, let's just think if we focus at 0. Focus at 0. So we focus at 0. So the first part actually is just the value when we plug in 0. So it's here, the value right here. Okay. And so we're going to calculate 1, okay? This is a 1. This is a 1. Okay, so we're going to calculate the value when it's 1. So let me draw this. Okay, now let's think. So we're gonna find the high right here. So first this first part. Okay, so we focus at 0. So a actually is equal to 0 now. So if it's f of a right here, so we just plug the value a in this function, e to the x. So we just have this value. It's 1. Okay, it's 1 right here. Okay, so we did this value. Okay, this is the first value, and the second value is the first derivative the first derivative of this point. Why we say it's this point? Because this point is actually if we're plugging in of this function, so we just actually think about so this part is the first derivative of this function, and we just plug in zero. So we just take the first derivative of this point, and we say the first derivative of this point. So we just, of course, we know, and we times it as x minus a. So this is this term. So and this is the first derivative of this point. So actually, it's the speed of this point. The speed of this point. And so we use the speed right here to times x minus a. I mean, actually, because x we're just finding the value of 1, so x is equal to 1, and then of course a is equal to 0. So the difference is 1 right here. So we use the speed to times 1, so of course we have a value here. Good. So, okay, so if we have this part, so now let's draw the derivative function. Let's draw the derivative function here. Okay, and this is 1, and this is 1. Okay, so good. So now this is the the first derivative of this function. So so we're gonna find right here we're gonna find the value of 1 right here. So right here we're gonna find the area right here. So let me tell you something first. So let's look at the first term. You see, the first term is f of 0. It is f of 0. So it's e to the 0. So actually we have a 1 in this value. But right here we can't see this value. But why I'll talk about later. Right here I'll tell you. In the derivative function right here we can't see this value. Okay, we can't see this value because this area is 0. Okay, so if it's like this, we can't see we can't see this value 1. So it's equal to, if we calculate the area right here, is equal to, we calculate the area this one. 1 point blah blah blah. This part. You can calculate this part because we don't have this part. I'll tell you this later. And so right here just equal to, we calculate this part. Okay. Good. And so right here first. Now let's think about this part. So this actually is the value right here. Is the value right here. Good. So we just use the value. Actually, it's a speed, right? So we'll just talk about a value right here. So we use this to times x minus a. This is x. X to equal to, and we can write this as a. And good. So we just have this area. Good. This area is this term. Good. So the next right here, because we talk about right here, this is the speed right here. Right. So right this point. Sorry. We can't see this part. So first, let's think about this part. We can't see this right here, and right here is just the speed of this point. Okay, let me use one. The speed right here. And so we use the speed to times x minus a. And so we have this. And of course, we're gonna find this area now. So let's think. So first we have, this is a, because, this part is a triangle. So we just, in a triangle, and this part is a triangle. And so we're going to calculate the area of this triangle, right? And we're going to calculate the area of this. And if we're going to calculate the area of this triangle, so let's derivative it again. So we have a line, straight line right here. Good. And we're gonna calculate from a to x. From a to x. So we just cancel out other places. We don't need it. So calculate this. And this high is this value. Actually, we know it's ED0. And we just times x minus a. So we have this area. Good. And we put this area back right here. We know it's this value. And we use this value. Of course. And we times this. So we have this area right here is this value. And we times this x minus a. It's rectangle. And we times another 1 over 2. So just the area of this triangle. Good. And now we have this triangle area. So we know the speed right here is the speed of a. It's the speed of a. We can write the speed of a. And so let's think about the next part. So the next part right here, we know because we have 3x minus a. So because this is, well, we know this is derivative function. Okay, so this is turned to a quadratic function. Okay, right here. So we're gonna calculate this area. So we can just move it like this. So first we have this. Then we can move it. We can project it like this. Good. So we find this area till we find this area. Good. And we're going to find this area. And we're going to find this area. So let's think. Let's think about its second derivative. So let's think about this part. So this part. So this one is a value function. And so we just times. So we are going to think about from a to x, from a to x. So we can get other parts. Good. This part, and we just find the area. Because we use this as our value right here. Of course, we know is this guy's second derivative. We can say this guy is second derivative. And so this is this value right here. And we times x minus a. So we have this area. And to this guy's first derivative. So we have something like this. So it's a to x, right? And we have this area. Why? Because if we have this area right here, so we have this value right here. And we just times another x minus a. And we times another 1 over 2. So we just have this area. And this triangle area, so let's go back to here. So we just have something like this. Quadratic function a to x. A to x. Quadratic function. Okay. Like this. So because right here, this area is equal to this value, and this value we times a minus x minus a, and we times so we just times x minus a, and we times another 1 over 3. Okay, so we had this area. Okay. So now if we have this area, just because we can project it back, so we just have this area. So the problem is easy because first we just derivative it to its second derivative. Now then we integrate it back. So you see, of course we see because when we integrate back, right, this whole part and this part, these two guys, both of them looks like both of them are this. The speed of point A. It actually is like this because it's inside the delta. It's inside the delta. Why is it actually like this? So this value right here is the speed of point A. The speed of point A. But the next term right here, I mean this whole part, is the speed of point A plus dx. So you see, dx of course is less than the delta. So this is, so if we see this guy, so we can't see it, we have a plus dx. So we just, if we see this, so we only can know that this is from point A. So we don't know there's a dx actually, but there is a dx actually, and so this speed is the point sorry, is the speed of this guy right here. Okay, so we know this guy's speed is the speed of point a plus dx. Okay, right here's the point. Okay, so this is the fourth part right here. So you can continue for the fifth part and so on. And of course, right here, let's think about actually right here, if we just focus at 0 and we calculate 1, and right here we just f of 0 right here is the intercept, and we just can't see this in the derivative function. And so let's think about what about if we just we just focus at 1 and we calculate at 2. So 2, the value is right here, and this point is 2. Actually, like something like this. And so the first term is f of 1, so we have this value. And the problem is the derivative function. Okay, let me draw another derivative function. We'll just talk about the intercept part. Okay, something like this, and we have a 1, and we have a 2. Good. Something like this, and so the first part right here is this area. But don't forget, we lost, because if this part, you see, because right here the first part is f of 1, so we just plug 1 in the original function, I mean dx, so we just have this value. And if you see the derivative function right here is this area, but in derivative we didn't have the intercept right here. We didn't have the intercept right here. So it's equal to in the derivative function right here. This area is equal to, we don't have this intercept 1, and we just only have this one, the 1 point, something like this, and this means this area. We know we can't see the intercept right here, the 1. So actually, this part we have f of a, this whole value. So actually, if we just put this in the derivative one, the first derivative function, this area is we can write it as f of a minus f of 0. F of 0 actually now means the intercept. Right here means the intercept. Okay. Okay, and so when we see this part, normally we can say it's it's very regularly. We just can say example or just something like we just use every different speed or gradient, every different speed gradient, and we just times some dx, and we just have this area, and can find, of course, we can find this area. So right here, it's no need for we integral from the derivative function, from the derivative graph, and we just plug the value in the original function, and we just had this value. So theoretically, so it's fine.